Canada is moving ahead with a new kind of nuclear energy, one that is smaller, faster to build, and designed to meet rising electricity demands.
I have to say that among the young nuclear workers, there is tremendous excitement about being world leaders in the construction of the next generation of the nuclear SMRs.
So Ontario Power Generation has received approval to build the G7's first small modular reactor, the first of 4, in fact. The project is expected to power around 1.2 million homes, but it doesn't come without
Something huge is being built deep under the ground in Canada, and the world has no idea watching closely. Experts say this secret massive project could change Canada's future forever, bringing more power, more jobs, and making the country stronger in a race many nations are trying to win. 35 meters below the ground, at the Darlington nuclear site on Lake Ontario, roughly 50 miles east of Toronto, a milestone was completed in the spring of 2026 that made Canada the most advanced nuclear construction jurisdiction in the Western world. The giant basement module, the foundation of the reactor building for the first small modular reactor to be built in a G7 country, has been set into place in the excavated reactor building shaft. That concrete and steel foundation, installed with components made from an innovative modular steel concrete composite material produced in Ontario, marks the point at which the Darlington new nuclear project formally became a nuclear unit under construction. The G7's first commercial grid-scale small modular reactor is no longer a plan or a permit or a licensing application. It is a building going up. The reactor being built is the GE Hitachi BWRX-300 megawatt boiling water reactor design that is approximately 10% the size and complexity of a traditional large-scale nuclear plant. Once in service by the end of 2030, the first BWRX-300 SMR unit will be capable of generating 300 megawatts of safe, low-carbon, reliable, Ontario-made power enough to power about 300,000 homes. Ontario Power Generation has contracted for 4 BWRX-300 units at the Darlington site. The full fleet, pending regulatory approvals, will produce 1,200 megawatts of electricity, enough to power approximately 1.2 million homes continuously, 24 hours a day, regardless of weather, season, or time of day. That last characteristic is the one that separates nuclear from the renewable energy sources that dominate current clean energy policy discussions. Solar panels produce electricity when the sun shines. Wind turbines produce electricity when the wind blows. Both are zero emission and increasingly cost competitive, and both are intermittent, requiring either storage or backup generation to maintain grid reliability when conditions are unfavorable. A nuclear reactor produces electricity continuously at its rated output for months between refueling cycles and years between major maintenance outages. In grid engineering terms, this is baseload generation, the foundation of a reliable electricity system that intermittent sources cannot provide on their own. Ontario's independent electricity system operator, evaluating the Darlington new nuclear project against alternative non-emitting generation options, concluded it was the best option to meet growing demand in terms of costs and risks when compared against non-emitting generation alternatives. The construction timeline Canada is executing reflects a delivery record that is specifically what makes the Darlington project commercially significant beyond Ontario's borders. The Darlington refurbishment, the decade-long overhaul of the 4 existing CANDU reactor units at the same site, completed its construction phase in early 2026. OPG will be leveraging more than 7,000 lessons learned from its Darlington refurbishment project. That refurbishment was completed 4 months ahead of schedule and $150 million under budget, extending the existing Darlington unit's operational lives to at least 2055. In the same month, Bruce Power completed its Unit 3 major component replacement on budget and ahead of schedule. 2 large nuclear projects, same month, both delivered reliably in a global industry where projects like Vogtle in Georgia came in $17 billion over budget and years late, and Flamanville in France is a decade behind schedule. OPG President and CEO Nicole Butcher stated, "This is truly a historic moment. This Made in Ontario project will support provincial companies, create jobs for Ontarians, and spur growth for our economy." OPG is proud to be leading this first-of-a-kind project. The economic dimensions of the SMR program extend well beyond the construction phase. Deploying and operating 4 SMRs is expected to increase Canada's GDP by $38.5 billion over 65 years, according to the Conference Board of Canada. The project is being built using Canadian steel, concrete, and materials, with skilled trades from across Ontario currently on site. The construction alliance includes Atkins Realis as architect-engineer, GE Hitachi, Nuclear Energy as reactor technology provider, and Aecon Kiewit as construction manager, a team that combines Canadian engineering capacity with proven nuclear construction experience. In April 2026, OPG submitted its application for a 20-year operating license for the first BWRX-300 to the Canadian Nuclear Safety Commission. The operating license application runs parallel to active construction, a sequencing that is possible because the design, review, and safety case for the BWRX-300 technology was completed through the CNSC's vendor design review process before the construction license was issued. That regulatory preparation, which OPG began in partnership with GE Hitachi in December 2021, is why construction could begin as quickly as it did, following the construction license issued in April 2025 and the provincial construction approval in May 2025. The Tennessee Valley Authority in the United States has selected the same BWRX-300 design for its Clinch River site. The TVA project remains in permit review and will not produce power until 2033 at the earliest. Canada's Darlington project targets first power by the end of 2033 years, ahead of the American deployment of the same reactor design, despite the United States having a substantially larger nuclear industry and a longer history of commercial nuclear operation. The Darlington project's role as what OPG's own documentation calls the proving ground of the Western world for commercial SMR deployment means that every delay Canada avoids is a demonstration of viability that every other country evaluating the BWRX-300 or comparable SMR designs is watching directly. Countries including the United Kingdom, Poland, Sweden, and multiple other jurisdictions are evaluating the BWRX-300 specifically because of Canada's deployment. GE Vernova CEO Scott Straszek stated, "As we confront the challenges of increased demand, energy security, and carbon intensity, this milestone reaffirms our commitment to innovation and a more sustainable energy future." The BWRX-300 standard design and factory-built components are specifically intended for replication at scale once Darlington demonstrates the construction methodology, schedule, and cost profile in a commercial setting. The pathway for subsequent deployments in other jurisdictions becomes substantially clearer and lower risk for both developers and regulators. OPG has also submitted applications for a proposed Wesleyville large nuclear project in Port Hope, Ontario, a site being considered for additional large-scale nuclear capacity beyond the SMR fleet. Ontario's power demand is projected to surge by 75% by 2050, driven by EV adoption, industrial electrification, data center growth, and population expansion. The Darlington SMR fleet will contribute 1,200 megawatts to that demand. The Wesleyville project, if approved, would contribute significantly more. Combined with the operational CANDU fleet, including the refurbished Darlington units now committed to operation until 2055, and the Bruce Power Generating Station, Ontario, is building a nuclear electricity system that no other G7 jurisdiction currently matches in scale, reliability, commitment, or construction execution. 35 meters below the surface at Darlington, the foundation is in. The reactor building structure is going up. The operating license application is filed. The first commercial grid-scale SMR in G7 history is under active construction, on schedule, targeting first power in 2030.